Okay, welcome to Algebra Cafe. We're going to talk a little bit about actually writing some systems of equations so that we can do some applications. So you can title these notes Applications of Systems of Equations. Okay, so this example. Scientists studied the weights of two alligators over a period of 12 months. The initial weight and growth weight of each alligator are shown below. After how many months did the alligators weigh the same amount? We're going to use the same model that you're going to use in class on Wednesday. So the problem tells us the initial weight and the growth rate for each alligator, and we have to find how many months did the alligators weigh the same amount. Okay, so we're going to write some pseudo-equations here. And pseudo-equations means equations that are part words and part math, not quite the full equation yet. Okay, so I noticed here that I've got alligator 1 and alligator 2. And I know about alligator 1 that his weight starts at 4 pounds and then he gains 1.5 pounds per month. And then I know for alligator 2, its weight starts at 6 pounds and it gains 1 pound per month. Okay, so the things that we don't know in this equation are the sort of the final weight of each alligator and the number of months. So I'm going to use my variables to be those unknowns. So W is going to stand for weight in pounds, and M is going to stand for number of months. And just writing that down really helps me figure this out. Okay, now I'm going to go to exactly what I have on my paper, and I'm going to try and figure out how this might be like an equation that I've solved before. This looks a lot like a y equals, that looks like a b plus an mx or something. So I'm going to write it kind of in that way. So for A1, again I have W equals 4 plus 1.5. 1.5 per month, so 1.5 times the number of months. And A2 is going to look similarly. Okay, so I've got these two equations, and I can decide how to solve them. I could graph, I could use substitution, or I could use elimination. Let's predict what we think the answer is going to be. Well, first of all, the answer is going to be a number of months because the question asked us how many months. Let's estimate how many months, just so we have an idea. All right, let's pick 10 as a number. That would be, if this alligator at 10 months is going to be 4 plus 15, so that'll be 19. And this one will be 16. So it's going to be less than that. Let's guess 8 or 9 months. Because I know it's going to be less than 10 months. Okay, that gives me a ballpark idea of where I'm going. So now look again at my equations. I think that these could be graphed because you could write them in y equals mx plus b. This being the y, this being the x. That's our slope, or our rate of change, and that's our intercept. Definitely could graph them. Because I think it's easier, a little bit easier, I'm going to use actually substitution. Because here I've got w solved for. And I can just take this whole equation and substitute in where the w is. That's one way of doing it. So I've got 4 plus 1.5m equals, so that was the w in the place of the w, 6 plus 1m. So all I did was substitute in the place for the w there. And now I'm going to let you go ahead and solve that. Once you find the m, you could also find the w. I think setting up and writing the actual system of equations, like we did right here, is the hardest part. So we're going to do one more example, just setting up and writing the equations. Okay, we're going to do this snack bar problem here. It says a snack bar sells 2 sizes of snack packs. A large snack pack is $5 and a small snack pack is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many small snack packs did the snack bar sell? Okay, so we know the cost of each type we know the total number of snack packs, and we know the total amount of money. And we want to know how many small snack packs. So let's go ahead and write our pseudo equations based on the information we have so far. Okay, so I know that in one day the snack bar sold 60 snack packs all together. So I know then that the number of small plus the number of large altogether is 60. That's one thing I know already. So that was about the amount, but there's this thing about the dollars too. So I know the total cost, which happens to be $220. That's equal to the money from the small snack packs plus the money that we got from the large. Okay. How much are we going to make from the smalls? Well, they sell for $3 each, so it's going to be $3 times the number of smalls. And the large, then, we're going to take in $5 times the number of large. It's $220. Okay, so this helps me really understand this a little bit better, because I can see now that I've got number of small, number of large, number of small, number of large. Okay, so I'm just going to use X and Y this time. X is going to stand for number of small snack packs, and Y is going to stand for number of large snack packs. Now I almost have the equations already written, so I'm going to go ahead and do that. X plus Y equals 60. That's number plus number equals total number. Now we're going to write the equation that's about the money. So I don't really need the dollar sign. 3x plus 5y equals 220. Okay, let's give an estimate of how much we think it's going to be. So if we only had small snack packs, like we'd have somewhere around 70, because 3 times 70 would be 210. And I know I only have 60 altogether, so my estimate is going to be somewhere between, say, if we've got 60 altogether, I don't know, somewhere 20 to 60. Alright, and that's not a very precise estimate, but if I get 520 or 2, I'm probably not right. So I can go back and check it. Okay, so now this system of equations really looks like I should solve by elimination. So I would probably go ahead and do that. By multiplying this top equation perhaps by -5, and then I've got 3x plus 5y, that's the equation I already have, equals 220, and -5x minus 5y equals -300, and now I've got -2x, so x equals 40. What did x stand for? X was the number of smalls. So now, to solve the whole problem, I'd have to go back and find the number of large, but something I notice is it says how many small snack packs. So I really already finished this problem, and I would say 40 small snack packs. And that's within my range of reasonability.